In this video, we're going to take a look at integration and the very basics of integration using indices, laws and rules. So for example, let's just take a straightforward polynomial to begin with. So if we have the integral of x squared plus 2x plus 3, what that is going to become under integration, which is anti-differentiation. So we're doing the exact opposite to differentiation. So we're going to be adding 1 to the power and dividing by the power. So we're going to say x cubed all over 3. The next one, plus 2x. We're going to add 1 to the power, so it becomes squared all over 2. And if we have 3, that is the same thing as having 3 by x to the power of 0. And if I'm to add 1 to the power, then it actually becomes 3 x to the power of 1 all over 1. And I'm going to put a plus c in here. And the reason why I'm putting in a plus c is because when we differentiate, the rate of change of a constant value is 0. Right? So we eliminated the constant whenever we would differentiate before. And now if we're reversing that process, we need to take into account that maybe there was a constant there that was eliminated when we did the differentiation. So we reintroduce the constant as a plus c value at the end of the indefinite integrals. So these are indefinite integrals, meaning that we're not given any interval between which to integrate. Now, this can be tidied up a little bit more. We could actually write it as x cubed over 3. That could be simplified down just to give us plus x squared, and this could be plus 3x plus c. So that's the very basics of integration. Now it does get a little bit trickier. So if we don't have a straightforward polynomial, so what if we had another example here? For example, what if I now had 1 all over x squared? How would I integrate that? Well, the first thing I would have to do is I would rewrite it in a way that gives it to me in index notation. So using indices laws, I can reverse that to give me x to the power of minus 2. And if you're unsure about how I did that, you need to go back and revise your indices. So what we do then after this stage is it's exactly the same as before. We're going to add 1 to the power and divide by the new power. So if I add 1 to that, I'm going to get x to the minus 1, and I'm going to divide by the new power, so I get minus 1. And then again, what happens here is I'm going to say plus c, because there could have been a constant there at the beginning, and I differentiated it, rate of change of a constant is 0, meaning it would have disappeared, and we need to account for that. So I'm putting in a plus c. Now this needs to be tidied up, so we would like to see it back in this format if possible. Now to the power of a minus means that it's the reciprocal, so we're going to put it under to the power of 1. If we divide something by a minus, it becomes a minus. So this is what we have, plus c. So that's another common one that you could get asked. The next one we could think about is if that's the integral of 1 all over x squared, what about the integral of 1 all over x? Because that's going to become the integral of x to the power of minus 1. And if I add 1 to the power there, I'm going to get x to the power of 0. And I'm going to be dividing by 0, which we know isn't allowed in maths. Now what you might remember is that if we were to differentiate something in particular, we would get 1 all over x. And if you check your log tables, you'll see that 1 all over x goes to ln x. So that one's nice and straightforward. And we must not forget our plus c. The next one then, for this example, the square root of x. So the integral of the square root of x. Again, the key is to bring it back to indices. So can I write that using index notation? So the square root you need to associate with to the power of a half. And what we would do there then is we would add 1 to the power. So we're going to get x to the 3 all over 2 all over 3 all over 2. And then when I divide by a fraction, when I divide by the fraction here, it actually becomes multiply. So flip it and multiply. So I get 2 all over 3. And then this, going back, use index notation and the indices laws to reverse that to become the square root of x cubed. And then we must not forget our plus c. Really, really important that we account for that constant that may not have been accounted for already in the integration or the anti-differentiation. Another example. What if we now had the integral of 1 all over the square root of x? So what if we had that scenario? So again, go back to your basics, go back to your indices. So I write it as x to the power of a half, and we're integrating that x to the power of a half, but it's 1 all over x to the power of a half. So 1 all over means that I could write it as x to the power of a minus a half. And instead of writing it as the fraction, I could bring it up and put it to the power of a minus. And then what we do is we do the exact same thing as before. We say add 1 to the power. So in this case, it's going to be x to the power of a half. And divide by the new power. So we get divided by a half. And plus c, because it is the indefinite integral. And then if I divide by a half, it's the same thing as multiplying by 2. So I've got 2x to the power of a half plus c. And again, you need to know that x to the power of a half is interchangeable with root x. So we get 2 root x plus c. So those are some of the most commonly asked questions for your basic integration.